All right, I'm recording again. Unfortunately, I hit the wrong button and ended the recording rather than restarting the recording. So there will be two recordings from today. One long one, about 2 hours worth, and one short one, about 15 minutes worth. So here is the beginning of chapter 15. All right. Now, picture's not quite up yet, but we'll soon be there. This picture itself, I don't think is in your book. This was an earlier one. This is actually a picture we have of, I'm pretty sure this is Neptune or Uranus, one of those two. It's a big storm cloud that's circling the planet. I'm pretty sure it's Neptune. I don't think it's Uranus. Okay? But it's a pretty fuzzy photograph because it's taken from a long way away, put together. Yeah, so this term, okay, we started with the universe, everything. And now we're going to focus on the solar system. Okay? Next chapter, Earth-Moon system. Okay? So we get even smaller. But the solar system, the core concept here is the solar system is composed of, number one, the sun. When you see solar, sol, that means sun. The sun, the orbiting planets, the dwarf planets, and then small solar system bodies. And there's a bunch of those, a big bunch of those. And even though this is a real nice, neat little picture here, and there are some things nice about the picture and good about the picture, there are some things that are wackily wrong about the picture, okay? Number one, the scale of the planets are, oh, it's hot. No, okay. The scale of the planets are not bad. If you look at the size here, Mercury is a really small planet, not much bigger than our moon. You can just barely see our moon. Venus is much larger, almost as big as the Earth, but not quite. Mars is much smaller, but considerably larger than Mercury. Then you have the asteroid belt. And then relative to the others, there's Jupiter, massive, okay, compared to these. Saturn, very large, with rings. And then Uranus and Neptune are almost the same size, okay? And that's the reason I was thinking it was Neptune, because it's usually pictured as being blue. Other things that are relatively correct here, Mercury and Venus have no moons. We have one moon, and it's a pretty good sized moon. Mars has two. They look a little too big for it. Jupiter has so many, it's unbelievable. Saturn has quite a few. Uranus and Neptune have quite a few each. Okay? So the relative sizes and kind of the number of moons, so to speak, not a bad thing. But what is totally wacko, remember I said not counting the sun. If you did this properly, the sun would take up almost all wall and everything else would be little dots out here. So in order not to get it so wackily, because you see, this makes it look like the sun may be twice as big as Jupiter. No. It's multiple times. Multiple times larger than Jupiter. Okay. Now, so that's just a little issue. A much bigger issue I have with this is the distances. They are nowhere. The order is right. The distances are nowhere close. And we'll talk about this a little bit later. If this is Earth, Venus is about 0.7 out to the Earth, so that's not bad. Mercury is 0.4 from the Sun to that, so that's not bad. Mars should be 1.5 times further from the Sun than Earth is. Okay, that's too tight. The asteroid belt's too close. And then these others, if these were correct, if these four were correct, these others would go past the wall over there. Okay? So obviously they can't do the relative distances right. Now, and the main thing that really gripes me about this, you never, ever, 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 ever will see these planets lined up like that. They're nowhere close. When Mercury's here, Venus is probably up here, or they're just all over the place. And you'll never, ever in a trillion years, or longer than that, ever see them line up like that. It just isn't going to happen. They're going at different speeds, different distances and stuff. It's just amazing. Okay? So, a nice little graphic, but nowhere close to reality. A few things are, the relative sizes are about the closest thing to reality. All right. Now, the first few pages in the book has a lot of really good information on it. And there's one thing here that I'm going to try to point out. I think it's on the slide, but if not, I'm going to point it out in the book, because there's a couple things that can be misleading. So I'm going to try to point that out. So, planets, moons, and other bodies. The International Astronomical Union. This is not something we control or any one country controls. It is truly an international union. And basically, I hate to say this because it sounds sort of snobbish, but it's so true. Say again?
It's okay.
Okay, all right. It's that scientists tend to get along better than any other general classification of people I know. Scientists from Russia and England and Europe and China and Japan and Australia, they mostly generally respect each other greatly and collaborate. It's a pretty good group. And organizations like this do a great job of keeping the playing field pretty level. Even wacko states like North Korea or at one time Uganda was, Venezuela, I'm not sure, but I bet you the scientists there, they still get along with others pretty well. So anyway, they are the governing authority over the names of those celestial bodies. And they're really fair-handed with it. They don't give any one country or group of countries any advantage over others. They work together really well. And the IAU are the folks who have defined what is a planet anyway, okay? What are dwarf planets? In fact, they didn't even have that classification before. They came up with it fairly recently. And then how they define what are the smaller solar system bodies. It was 2003. That's during most of your lifetimes, right? Okay. 2003, Pluto used to be called a planet, no longer. It's redefined as a dwarf planet according to the IAU definitions. Okay? And I'll give you just a few of the reasons now. Remember I said that most of the planets, the sun in the middle, most of the planets go in close to circular orbits around the sun, all within pretty much a plane. There are a few deviations and stuff, but generally within a plane, a thick plate anyway. Okay? And Pluto. The other planets are like this, not too far off. Pluto like that. So its plane is way out of sync with the others. Okay? And I said most of the others are fairly close to circular orbits. They're all elliptical, but fairly close to circular orbits. Pluto's like this. Very elliptical. Okay? The other planets, we're going to talk about this later. The 4 inner planets are rocky and small. The asteroid belt is next. The 4 outer planets, gaseous. Giant planets, huge, okay? Pluto is more like a rocky planet. It's out of place. I mean, it doesn't even fit, And then the size of Pluto, I think Pluto, I'm pretty sure of this, is smaller than our moon, okay? And we don't have the biggest moon. Jupiter has 4 moons, way bigger than ours. Saturn has, yeah. What's that now?
Saturn moons, one of them is bigger than Mercury.
Our moon or what other moon?
Saturn moon.
Saturn's moon. Yeah, Titan. Remember the Titans? Okay, no, that was a football story. But yeah, the Titan is far bigger than Mercury. Okay. Pluto, way bigger than Pluto. Okay. Yeah. And yeah, so you're absolutely right. But all those things basically said, yeah, Pluto doesn't fit enough criteria to be called a planet. So it's called a dwarf planet. Okay, how are we doing, folks? Ooh, it's close to time. All right.
We've got about 4 minutes.
Yeah.
Excuse me, what time is it?
I'm sorry?
What time is it?
341.
3:41, and we start the lab at 3:45. I want to mention to you, because they do mention dwarf planets. Right here it's talked about, but nowhere else in the slide set will you see dwarf planets mentioned very much. So let me give you the 5 dwarf planets. It's in the book on that very first page. That's why I said this is pretty important. I know I just saw them, but I can't see it now. Yeah, here they are. It's on page 379, the second column. Because Pluto does not clear its orbital zone, it was recharacterized as a dwarf planet. Today there are 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And at least 5 dwarf planets. They may name some more later, but these are the ones. Pluto, then there's one called Eris, E-R-I-S, one called Ceres, but that's spelled C-E-R-E-S. And the next 2 sound like they were named from Hawaii. I don't know. Makemake, M-A-K-E, M-A-K-E. I may be mispronouncing it, but I think that's how you say it. And Haumea, H-A-U-M-E-A. Now, there's many, many, many smaller solar system bodies. But then the next sentence here is one of the most important sentences in the book. The sun, our sun, Sol, remember him, has 700 times the mass of all the planets, all the moons, and all the other smaller bodies out there. Added together, the sun is more than 700 times as massive as everything else in the solar system put together. So therefore that sun should have been huge and the planet's little specks of dust out there, okay? Because everything added together is 700, the sun is 700 times more. Later there will be a slide that says something about the minor members are the most massive part of the solar system. Not counting the sun. They forget to put that phrase in there. Because the sun is bigger than, 700 times bigger than all the rest of it put together. So I just wanted you to be aware of that. Okay?
1 more minute.
Second?
1 more minute.
Yeah, I think that's where we're going to stop today. We'll start next time with the solar system. I'm trying to find this in the... Okay. This is basically, I don't know what slide number this is. This will be planets, moons, other bodies. Okay? No, I guess, yeah. Okay, I'll start it there. Okay. We will end this today. Well, no, we're not going to end this today. We're going to pause it again.